Okay, so today what we're gonna do is we're just gonna continue on with the characteristics. Sometimes it's called properties of quadrilateral. So last time we said quadrilateral. The word quad means four, lateral means side. So if you put those two words together, those two meaning, quadrilateral means four-sided figure. So we're talking about anything that's four-sided figure. So just kind of refresh our memory, and like I said, I will post all of these on the blog as soon as we're completely done with the lesson 1. So the first one that we talked about is a parallelogram. So these are the characteristics of a parallelogram. Okay. And then last time we talked about a rhombus, which is a special parallelogram. And we said these are all its characteristics. And then this one we are very, very familiar with because everybody knows rectangle. So a rectangle is a special parallelogram, and these are the characteristics. So we wrote that last week. If you weren't here last week, you can find that on the blog. Now we're just going to continue on with the next ones. So square. Everybody know what the squares look like? So let's take a look and see. How do we describe this square? So what can we say about side length? Any sides congruent? Any sides congruent? All sides are congruent. Okay, so all sides are congruent, or we can say equal. Okay, all sides are equal. So, and how do we know that on a picture? How do you show that on a picture? We say that this side, which is this tick mark, and you see this one tick mark there, that one just tells you that all of these four sides are equal. Are the sides parallel? What does it mean by parallel? Yeah. Oh, do you have one? No. Okay. Are any sides parallel?
Opposite sides?
Yeah, we can say opposite sides are parallel. Okay, parallel means they're going in the same direction. So these two lines are going in the same direction, and then these two lines going in the same direction that way. So opposite sides are parallel. Okay. Any sides perpendicular? Well, what does it mean by perpendicular? So yeah, they create a right angle on that corner where they meet, and it says here, okay, this line here, the vertical line is perpendicular with this horizontal line, and then this horizontal line is perpendicular with the vertical line, and then this vertical line is perpendicular to this horizontal line. So how do we say that? What did we use last time? So perpendicular sides, we use the word consecutive. Consecutive sides are perpendicular. Consecutive sides. The word consecutive means one after the other. So one after the other. Would it be okay if I turn off the lights? Would that make it better for everyone? This one. Okay. Now what about diagonals? Diagonals are the one from one corner to the other. diagonals is these ones over here. You're going from this corner to the opposite corner. So those are diagonals. Are diagonals congruent? Do you think they're all this? Do you think they're congruent to each other? Do you think they're equal in measure? Yeah? So if you measure it out, this and then this, yeah, they are congruent. Yes. Are diagonals perpendicular? Do they create a perpendicular? Do they make a 90 degree somewhere? Yes, right? Because if you take a look at, zoom this in. I'm going to zoom this in here, if I could. Right there. This is part of the part of diagonal. This is part of diagonal. Can you see? This creates a triangle, and then there's a 90 degree right there. That creates a 90 degree angle in the middle, which means they are perpendicular with each other. So this diagonal and this diagonal are perpendicular with each other. Okay, so zoom that out a bit. So are the diagonals perpendicular? The answer is yes. The next one, do diagonals bisect each other? Bisect meaning to cut into two equal parts. Yes, okay. Yes, because think of this as this diagonal cuts the other diagonal into two equal parts. This and this are the same. In fact, all of these from the center, can you see it? From the center to the corner, 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 these four lines are equal to each other. Okay, that's why you have those two lines indicating that those are all four of them are equal to each other. And then lastly, what about angle sizes? Are any angles equal? Yes? Yeah. So these are called interior angles because it's in the inside of the square, interior angles. And what do we say? All interior angles.
Exterior.
Interior. Oh, we'll talk about the exterior as well. All interior angles are equal. And in fact, they're equal. And they're equal to what? 90 degrees. And they're equal to 90 degrees. Okay? So those are, when we first learned about square, the only thing that we know about is that all four sides are equal, right? And maybe all angles at the corner are 90 degrees. But we didn't quite explore the other characteristics of a square. And these are the characteristics. Okay. Ooh, this one. It's called a kite. What about side lengths? Any side lengths that are congruent, that are equal? Any side lengths. So these two are congruent, right? Because you got those two little tick marks right there. And then these two are congruent to each other. So in a kite, so two sides, two congruent sides are equal to each other, and then the other two congruent sides are equal to each other. Okay? So oh, not the word congruent. Oh no, I don't have my two. I don't want to say two consecutive sides are congruent, and another two consecutive sides are also congruent. So these two consecutive sides are equal to each other in measure, and then the other two consecutive means one after the other are also congruent. Any sides that are parallel, they're going in the same direction?
None.
None. Okay. None. None are parallel. So how do we know that? So if you look at this side, it's not going to be in the same, they're not going in the same direction. Kind of look like it, but this one is probably going much faster. This one's not as fast. Any perpendicular sides? Any perpendicular sides? That means any 90-degree angle. So this line or this side is not perpendicular to this side, and then this side is not perpendicular to that one. You notice that there's no square on each corner right there. So any perpendicular sides? No. Are diagonals congruent? Okay, so are the diagonals congruent? You have this diagonal, and then you have this diagonal. Or do you think they're the same length? Same measure? Is everybody okay with that? If we say no? So we can say that, oh, I can see that this is shorter than this one. Are the diagonals perpendicular? The diagonals perpendicular. So this line, this is a diagonal from one corner to the opposite corner. Do they make 90 degrees? Yes. Yes, they are. So they're making a 90 degrees right here on a corner. Do diagonals bisect each other? Do diagonals bisect each other? So this diagonal here cuts this diagonal into two equal parts, right? That's why there's like a one line there and then a one line there, okay? But then, if I turn it around, do you think this diagonal cuts, no, this diagonal cuts this diagonal in half? No, right? You see, it's not. So how can we say that? Do diagonals bisect each other? No. And we can just continue on. Only one diagonal will bisect the other diagonal. Oh, I tried to squeeze that in there. So only one diagonal will cut the other diagonal in half into two equal parts. Okay, here's the last one for that. Angle sizes. Are there any angles that are equal in size? Are there any angles that are equal in size?
4.
Interior angle. So this one, can I cut it in? If I look at, if I cut this in this direction, what do you see there? It's a triangle. Okay, it's a triangle. Like, we can take a look at the triangle up there. It's called an isosceles triangle, right? Isosceles triangle, meaning these side and then this side are equal to each other. That means this angle and then this angle are equal to each other, right? I'm gonna turn it upside down. I'm gonna turn it upside down. I'm gonna cover this part. What does that look like?
Same thing, same triangle.
It's an isosceles triangle again, right? Because this side is equal to this side, so that means this angle and this angle are equal to each other. So what does that mean? So if these two are equal to each other and these two are equal to each other, if we can combine them, are they still equal to each other? Yeah, they are. So what does that mean? Okay, only one one set of opposite angles are equal. So only these two angles are equal. These two are not equal at all. So these, the angle up there and the angle down here, are not equal. And it can't be, right? Because anybody here has seen a kite? You don't see much kites anymore.
What about the interior angles?
Yeah. So those are the interior angles. Those are interior angles. So here's a kite. I'm gonna make a kite here. This is a really nice one. So these ones are equal. These are the interior angles right there. Interior. Now if we measure these ones and it's opposite, can you see that it tapers down in here? It tapers down. So it means that this is smaller. So if these two, looks like it's a wide angle, this one is more like a narrow angle. So they're not the same. But these two are. These two angles are equal to each other, but these two, no.
What about where the two lines bisect?
Oh yeah. So these ones, yeah, These ones create a 90-degree angle right there. So, did I even ask that? No, they didn't. Let's add it in. I think that's what you were thinking about, right? Are the diagonals, or are diagonals perpendicular? Oh yeah, we did. There we go. Are diagonals perpendicular? Yes. Is that good? Oh, is it okay to move it to the next page? Yeah?
Read it again.
Oh,
Only one set.
only one set of opposite angles are equal. Just these two. Okay, let's go to the next page. Oh, thanks so much. Oh, you got your name? This is your name? Okay. Okay, now we're gonna get into a trapezoid. Okay, it's still a quadrilateral. Okay, what does a quadrilateral mean? Four-sided figure. Yeah, it still fits. It's a four-sided figure. But let's take a look. Side lengths. Oh, let's see here for a second. Isosceles. Where did we see the word isosceles?
Triangles.
Yeah, the triangle, right? In a triangle. Isosceles triangle. What does an isosceles triangle mean?
Two equal lengths.
What's that? Two sides are equal. Okay. So, well, isosceles trapezoid. Interesting. So, I'm going to show you how that came to be. Okay. So, I'm going to go here. I'm going to try to create isosceles triangle. So, this and this are, it's called isosceles triangle, right? These two sides are equal. Well, how can I make a quadrilateral from this? Well, what I could do is I could take that off. Take the top piece off. Okay? What does that mean? Well, now it means that these two are equal. Okay, now it's a so if I don't fold it, it looks like an isosceles triangle. And then if I fold it like that, it's an isosceles trapezoid. Isosceles trapezoid. So what can we do? What can we say? Side lengths. Any sides that are equal. Any sides that are equal? This side and this side are equal. So it's only one set of opposite sides are equal. Okay, so those are the only two sides that are equal. Those two sides are equal. Now what about, are they parallel? Are these, they're equal, but are they parallel? No, right? No, because they're not going in the same direction. They're kind of tapering in. Are these two sides equal? This looks really obvious, right? Because this top part is shorter than the other, so they're not equal. What about parallel sides? Are there any parallel sides? Which ones do you think are parallel?
Now you got one set.
Yeah, which ones do you think is parallel? Top and bottom. Yeah, top and bottom. Right. So what can we say? One set of opposite sides are parallel. Yeah, only the top and bottom are parallel. Okay, next one. Perpendicular sides. Any perpendicular sides? No? Okay, so none of these corners make 90 degrees, right? So, no, nothing. Are diagonals congruent? Uh-oh, they forgot to draw the diagonals here. Can we draw a diagonal? Let's try that. Let's draw a diagonal. So how do we draw a diagonal? So one corner to the other, and then one corner to the other. What do you think? Are the diagonals congruent? Are they the same length? Yes, yeah. I can see like some people are using their imagination. It's like we don't have to measure it, but yeah, it should be equal, right? The diagonals are equal. Yes, they're congruent. Are the diagonals perpendicular? No. Anything that makes 90 degrees on each? No. Do diagonals bisect each other? So that means this diagonal cuts the other in equal parts. Oh, yeah, that one is a little too obvious, right? This is shorter than the other, okay. Any angles that are equal? Any angles that are equal? I'm gonna erase this part here. You can probably see it better. Do you see any angles that are equal to each other?
Yes.
Yeah, so these two are equal to each other. Do you think these two are equal to each other?
I think they would be, yeah.
Yeah? Okay. Yes, they are. Okay. So, yes. Two sets of consecutive angles are equal to each other. So the bottom pieces are here. The bottom ones are equal to each other, and then the two top ones are equal to each other. Oh, if you actually look over to that side, where both Damien is sitting, the one with the pop there, that's a trapezoid. So if you take a look at their table, and I'm pretty sure you've sat at the table before, that table over there, the gray one. If you sat at the table, that one is an example of isosceles trapezoid. So actually we call it traps, because it's a trapezoid. Okay, so that's that part. So this is called isosceles trapezoid, right trapezoid. What makes this a right trapezoid? Okay, I gotta draw you another picture. Where did we see the word right before?
Triangle.
Right triangles, yeah, right triangles. So what does a right triangle look like? What does a right triangle look like? Kind of looks like this, right? So Right trapezoid, it starts off as a right triangle. And then what would I do to make it a trapezoid, a four-sided figure?
Fold them down.
Fold the top over. Okay. So this is still, oops, a right angle here. And then this one, I'm cutting it horizontally so that these two, the top and bottom sides, are parallel to each other. So see, starting off with the right triangle, yeah, right triangle, and if I cut it, fold it in, right trapezoid. So now let's take a look. Any side lengths congruent to each other. Anything that are congruent to each other.
No.
So this one and this one, they're not the same length, right? And then this one is too obvious. They're not the same length. So any side lengths that are congruent? No, none. Parallel sides, are any parallel sides?
Yeah.
Okay,
One set.
only one set. One set of opposite sides are parallel. Did you know that there's a shortcut to writing down the word parallel? Did you know that? You know, like mathematicians, they write so much, right? And they tend to get lazy about writing parallel, perpendicular. So, any idea on how they write down the word parallel? Hmm? Yeah, but like, well, that one tells us, yeah, those ones indicate that they're parallel to each other. But the word parallel, how did they write the word parallel?
Take a guess.
Hmm?
PR.
2 lines, yeah. Yeah, they go like this. Parallel. Yeah. Any guesses on what mathematicians write down when they write the word perpendicular? Well, they don't really write the word perpendicular, but how do they show perpendicular? An L? Oh, pretty close, pretty close. It's actually perpendicular like that. It's like an upside down T. Yeah. Parallel, 2 slash, like 2 lines going perpendicular. They use that symbol to show the word perpendicular. Yeah, I guess they have better things to do instead of writing everything down. Okay, so perpendicular. So perpendicular sides. Are there any perpendicular sides? You only see one right here. Only one perpendicular what's the right way of, how would you say that? How would we say that only this one is the only perpendicular? One set of, okay, how do you say this line and this line? One set of consecutive sides are, okay, I'm running out of room. I'm going to use the word perpendicular, but not use the whole word. There you go. Just because. Is everybody okay with that? The symbol, perpendicular. Right? So one set of consecutive sides, oh, I gotta put sides, are perpendicular. So just this one and this one. And it's consecutive because it's one after the other, right? Not opposite. Okay, now this is gonna use we're gonna use your imagination here. So imagine you're drawing congruence. You're drawing congruence. Diagonals. Okay, draw your diagonals in your brain. Or here. If you don't want to do that, I'm a visual. I wanna be able to see what I'm doing. Okay, I got two diagonals there. Are the diagonals congruent? We're gonna use our imagination. Are they equal to each other in measure?
No.
No. So this one here kind of stretches out, right? So that one is longer. So the answer is no. Are diagonals perpendicular? Are diagonals perpendicular? So this is the diagonal, and then this is the diagonal. If I measure the angles here, 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 and here, are they making a 90-degree angle on them? Only one? Oh, this, and this? Not this one. Maybe I didn't do a good job. I'm gonna try to do a better job than that. So I'm gonna draw it with the ruler. Do you see a 90-degree angles? Or a 90-degree angle in any of them? See, what about the 90 degrees is that if this is 90, then the next one has to be 90. And if this is 90, then the next one has to be 90. And if this is 90, then this has to be 90. Because remember, when you have a straight line, that is called, what do we call that again? When two angles add up to 180, it's called supplementary angles. Zoom this in manually. Okay, so this is one line, and then this is 90 degrees right there, but it didn't stop at 90, it continued on.
No, that's like can't be.
And then let's do the other side. So this side rotates all the way. This is up to here is 90, but it didn't stop there. It continues on, so that's more than 90. And then from here, that's less than 90. So are there any perpendicular? No, there isn't. Any perpendicular diagonals? No. Do diagonals bisect each other? Do they cut each other in two equal parts? No. And any sizes, are there any angles of equal size? No. This angle, no. So, what do you think about this angle? Approximately how big is this?
90.
So this is 90. Do you think this is less than 90? Or
It's
the whole thing?
more than 90.
More than 90, right? Can you see it's more than 90? What about this one? Is this 90, more than 90, or less than 90? Less? Is everybody okay? What about this one? Well, I gotta change something in here because this one here is not gonna match that one. Gotta get back to this one. What do you think this is? Another 90. So they're like, oh, that actually I made a mistake there. So this one should be two 90-degree angles. So right there and right there. So let's fix that one. So 90-degree there, 90-degree there. So two angles are 90 degrees. Okay. So that concludes all of them. Can I ask you something? Of all of those quadrilaterals, how many diagonals are there all the time? How many diagonals? How many diagonals do they have? Let's take a look again. Parallelogram, how many diagonals does this have? 2. 1, 2. What about the rhombus? How many diagonals does it have? 2. 1, 2. 2. 2. 2. There's 2. So all quadrilaterals, any four-sided figures will always have 2 diagonals. 2 diagonals. Okay, so that concludes all of the notes. If you weren't here last time and you didn't get the first part, I will post it on the blog and I will keep it up here if you're still wanting to write it down. But for now, I think the rest of the time we can answer some of these questions on your assignment 1, and that will help us with some of the other questions we will see later on.